Okay, so now I'm going to be showing how to solve equations that have a lot of fractions in them, and how can we eliminate these fractions? Like, what is an easier way to just get rid of them instead of having to be adding, multiplying, subtracting fractions over and over again? So remember, when we were adding and subtracting fractions, we had to look for the LCM, right? The least common multiple of the denominators, or the least common denominator. And that's exactly what we're going to do right here. So remember, the least common denominator, it's the least multiple that all of the denominators have in common. Now, for the denominators, we have 6, we have 4, we have 2, and we have 12. And that least common multiple, it's going to be 12. Because 4 times 3 is 12, 2 times 6 is 12, and then 12 times 1, it's 12. So this is what's going to help us get rid of the fractions on the equation. So what we do with that 12 is we're going to go ahead and multiply every single term by 12. So we're going to multiply this by 12. We're going to multiply this by 12. We're going to multiply this other side by 12. And then by 12. Okay? Now let's go ahead and try to reduce before we rewrite our equation. So for instance, here we know that 12 and 6, right? 6 goes in both, so this 12 can become 2. And this 6 becomes 1, right? 12 and 4, both can be reduced by 4, so 12 becomes 3, and 4 becomes 1. 12 and 2, right? 2 goes in both, so 12 becomes 6, and 2 becomes 1. And then here 12 and 12, well, 12 goes in 12, so they both become 1, right? So now we end up with 2 times 1, which is 2x, right? So we're going to keep the x. And then we can put over 1, since we still have that 1 with the 6, right? And then plus 3 times 5, which is 15, and then still have over 1, equals 6 times 1, which is 6, and then over 1, and then the x, minus 1 times 5, which is 5 over 1. Now, we don't need these ones, so I can just rewrite this as 2x plus 15 equals 6x minus 5. Because we know that any number divided by 1, it's just the number itself. So now here we can go ahead and draw that line separating both sides of the equation, and I'm noticing that I have the variable x in both sides of the equation. So I have 2x here, and then I have 6x here. Now remember, we always want to move the smaller amount with the x, right? So the smaller coefficient. We can see that the smaller coefficient is 2, right? So this is a smaller, let's say the smaller term of x. So that's the one that we're going to be moving to the other side. Because it's positive, we're going to subtract 2x on both sides. So 2x minus 2x cancels out. So we end up having 15 on the left side equals 6 minus 2x, which is 4x minus 5. Now from there, we are going to get rid of the 5 in order to isolate x, right? So plus 5 on both sides. So 5 cancels out, and I end up with 4x equals to 20. And 4, right, it's multiplying x, so we divide by 4. So 4 divided by 4 gives you 1, so this is 1x equals to 20 divided by 4, which is 5. So x equals 5. and we have solved our equation. So remember, the first step is to always find our LCM and then multiply every single term in the equation by the LCM, right? And in that way you can go ahead and reduce the fractions. So this is when we have fractions. Now let's go ahead and work with an example that deals with decimals. So for the next example, we're gonna have 0.08 k minus 0.2 times k plus 5 equals negative 0.1. And for this particular problems, what we want to do is we want to multiply both sides of the equation by the smallest power of 10. So we know that it's the smallest power of 10 by the number of digits after the decimal point. The more digits that the number has after the decimal point, the smallest the power of 10. Remember that 0.1, so when you have one digit after the decimal point, that's 1 over 10, right? And then 0.01, that's 2 numbers after the decimal point, that's a 1 over 100, which is smaller, right? It's a smaller amount than 110. And then if you have 3 numbers after the decimal point, that's 1 over 1000. So the more digits after the decimal point, the smaller the number, the power of 10. So in this case, we have 0.08, so this is 2, right? 2 numbers after the decimal point. Then we have 0.2, this is 1, right? And then we have negative 0.1, which is only 1 decimal point. So one digit after the decimal point. So we can conclude that the smallest power of 10, in this case, it's 0.08. So this right here, it's the smallest power of 10, which is 1 over 100. So what we're gonna go ahead and do, we're gonna go ahead and multiply by 100. So to get rid of the decimals, we'll multiply the entire equation by 100. So we are gonna go ahead and have 0.08k minus 0.2 times k plus 5 equals negative 0.1. And all of this will be multiplied times 100. Okay. Now what that 100 is going to do, remember that when you multiply by powers of 10s, you're basically moving the decimal point to the right. Okay, so here we're going to be moving the decimal points twice to the right. So moving decimal points twice to the right. So instead of having 0.08, this decimal point is going to move twice. So it will become 8k minus, now this 0.2, again we move it twice. So it's going to be filled in with a 0 right there. So it's going to become 20 times k plus 5. Notice how I did not touch the k plus 5, because by moving the decimal point of the 0.2, I'm already multiplying the k plus 5 by 100 as well. And then equals and then the last digit as well, right? So this will be moving once, twice, right? So this will be 10. Okay. And now we can go ahead and apply our distributive property for the -20. So we're gonna have 8k minus 20k, and then -20 times +5, it's minus 100, equals 10. Okay. Let's go ahead and simplify our left side. We can see that we can combine 8k and -20k, which is going to give us -12k minus 100 equals 10. I'm going to go ahead and add 100. So then it cancels on the left side. I end up with -12k equals 110. And then we divide by -12 both sides. So -12 divided by -12 becomes +1. So +1k equals 110 over -12, or -110 over 12. And I'm going to go ahead and divide this by 2, since both are even numbers. So k equals -55 over 6. And that's my final answer. So again, you need to figure out which one is the smallest power of 10 by finding the number that has more digits after the decimal point. And then in order to get rid of the decimals, you multiply by that power of 10. So in this case, that was 1 over 100, right? Because we had two numbers after the decimal point, so we had to multiply times 100, right? Which is 2 zeros, two numbers after the decimal point, and then every single decimal that we have in the equation will have a movement of the decimal point twice to the right, because we're multiplying. So this was twice as well. Okay.